Yo, 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 this is Coach Ray. Back at it with another old school YouTube video. This one's on graphing quadratics, but it's about so much more than just graphs of quadratics. All right, here we go. First, here's an equation in standard form. Okay, you know standard form. I'm going to do two things to that. I'm going to put it in vertex form, and I'm going to put it in factored form. Okay, and then we're going to look at how vertex form and factored form relate to a graph so that we kind of connect everything all together. All right, so let's get started. And I do want to mention this now, how I initially taught, and on the last video, how I taught to switch from standard form to vertex form. It involved fractions. I'm going to show you today how to switch from here to here without fractions happening. Okay, and I'll try to do that without confusion. Step one. I am going to factor out this 2 because you cannot complete the square if you have a leading coefficient other than 1. And for people that were absent yesterday, how you switch from standard form to vertex form is by completing the square. That's what it's called. But everybody forgets, but you cannot complete the square if you have a leading coefficient other than 1. So I just factor it out. Piece of cake. Okay, if I move the 2 out and leave my x squared in there, 2 times x squared gives me 2x squared. Okay, so next one, to get negative 4x, I'm going to do negative 2x. So 2 times negative 2x will give me negative 4x. This problem, I can factor a 2 out of that 6, and it would just turn into a 3. So in this particular problem, there wouldn't be a fraction. However, all of the problems on your last assignment, this was an odd number, so it ended up turning into a fraction. I'm going to teach you how to do it so that you don't turn it into a fraction, even though this particular one wouldn't. Okay, so I hope I'm not confusing you there. I'm just factoring the 2 out of these front 2, and because this potentially could turn into a fraction, I'm just leaving it out there. I am allowed to just leave it in the back and not have it be any part of what I'm doing here. Okay, so the next step would look like this. Y equals 2 times x squared minus 2x, and I'm leaving room for me to complete the square right here. Okay, so notice the 6 isn't part of this, it's just chilling in the back. If it were an odd number, it would just be chilling in the back with no fraction. Okay, and now I can complete the square. How you complete the square is you cut this guy in half, b, the middle guy. Negative 2 cut in half is negative 1. Negative 1 squared is positive 1. Please listen very carefully to this next part. This is where you are going to mess up if you do it this way. It looks like I just changed the problem, right? I got to do something else to make sure I didn't just break the law and change the problem. Okay? It appears as though I added 1 to this problem. I did not. I added 2 to this problem. Does anybody see what I'm talking about? Distributive property. So this 2 is actually multiplying by everything in here. So when I put plus 1 right here, I actually put positive 2 into this equation. Okay? So if I put positive 2 into this equation, then I've got to do the opposite back here and put negative 2 into this equation. Is it possible that I factor a negative 2 out? Yeah, that's possible. If I factor the negative 2 out, the negative 2 times 1 would be negative 2. So in that case, I would have to do plus 2 back here to keep it balanced. Question?
So you know how you said you have to make it the half? Like the half of the negative 2?
Yes.
So do you change the sign? Because if it's half, wouldn't it be negative 1?
Yes, so great question. So the question is about signs when we're cutting in half and squaring. Negative 2 cut in half is negative 1, but negative 1 squared means negative 1 times negative 1, so we get positive 1.
Oh.
So what we put in right here is always going to be a positive number because whenever we cut in half, whether it's positive or negative, when we square it, it turns back to positive. That's a great question. All right, so I put my number in here. I didn't break the law. I can now clean this up and make this look a lot nicer. I've got y equals 2. This factors beautifully. People that were absent yesterday, you're going to have to watch the video to see more about this. But if I factored this, I get x minus 1 times x minus 1, which is x minus 1 squared. Okay, negative 6 and negative 2 is negative 8. And just last time I'll refer to this. If that was a negative number like negative 7, before, when we had it in here, it turned to a fraction, and then when we multiplied back, it turned back into a whole number. We just didn't need to do that. We could just let it chill out back, and now when we combine, it's still just a whole number. Okay, all right, here's my vertex form. I will write it underneath here. Y equals 2 times x minus 1 squared minus 8. All right, while I'm at it, why don't I write what the vertex is too? Opposite of this sign, So positive 1, same as that sign, negative 8. I'm going to go put that on my graph. Okay, write 1 down, 1, 2, 3, 4, 5, 6, 7, 8. I'll label it 1, comma, negative 8. That's my vertex.
Is that the dog's nose?
Yes, that is the dog's nose. All right. Alex did something weird that I didn't realize until yesterday. When they were having you sketch the graph on Alex, they were asking for like 2 points on each side. So they wanted you to plot a total of like 5 points. Then you hit the curve button and it puts the graph on. Let me show you how to do that. I would have showed you yesterday. I just didn't realize Alex was going to ask that. Watch this. This should make sense. I now know, and we know that all parabolas look like this. Oh, that was good. Do you get that on video? That was freehand. I just freehanded the perfect parabola. I'm going to leave that up here. All right. This is a perfectly symmetrical parabola. Did you know parabolas have symmetry? I hope so. Yeah. Okay. Your vertex is here. It's such a beautiful parabola that I forgot what I was going to say over here. Oh, yeah. Thank you. So we have points on this side and points on this side, and they're symmetrical. Okay, so I know this one's exactly in the middle. So if I know that this is exactly in the middle, I just want to pick a point to the right of that and see where it's going to be. So if this is at 1, I want x to be 2 and figure out where is the parabola when x is 2. Watch this, we can do it in our head. And your group is distracting me, please stop. Okay, if x is 1 here, I want to go to where x is 2 and figure out where the point's going to be. Come back to either the original equation or my vertex form equation. I think this one's a little bit easier. And I'm going to plug a 2 in for x to figure out what y is. So if I plug a 2 in, 2 minus 1 is 1. 1 squared is 1. 2 times 1 is 2. 2 minus 8 is negative 6. So when x is 2, y is negative 6, meaning 2, negative 6 is a point on this parabola. And because of symmetry, I could do the one on the other side too. This went over 1 up 2, boom, over 1 up 2. I know that there's a point right there also because I know parabolas are symmetrical. Okay? And I think Alex wanted 5 points, so I'm going to do another one. I went over to 2, now I'm going to go over to 3. So come here. 3 minus 1 is 2. 2 squared is 4. 4 times 2 is 8. 8 minus 8 is 0. So when x is 3, y is 0. Okay? And I know because of symmetry, this one's going to be on the x-axis as well. This is negative 1, comma 0. Make sense? Yes?
Can we just plug in that in Desmos and find out?
Yeah, but the issue people were having when they just plugged this into Desmos was finding actual perfect points. I had a lot of students yesterday really struggling dragging the mouse across the parabola in Desmos trying to find perfect points. If it works better for you, feel free. This only took me 15 seconds. Either way. Okay, all right. Let's go to factored form. Okay, you've got to take your brain back to back in the day when we were solving quadratics by factoring. That's kind of what I'm going to do here by switching it to factored form. I'm going to just tell you right now, one thing I'm worried about with your quadratics test is you know a lot of different stuff with quadratics. If I ask you for the vertex, I don't want you to start factoring. If I ask you for factored form or what that does in the graph, I don't want you to start doing completing the square stuff. So there's a lot of information that you need to know when to use. All right, but let's factor. Way back in the day, we did this. I'm going to just kind of bring this over here. If there's a greatest common factor, that's what we started with when we were switching to factored form. Okay? Notice I did factor the whole thing. I just didn't do the front two. The front two was just for the completing the square stuff. Now that I'm factoring it, if there's a greatest common factor, I factor it all out. If there's not a greatest common factor, that's okay. I just draw my square and start trying to figure out how to factor it. Okay? But since I did my greatest common factor, I'm going to move my square down here just so I have room. And I need to factor what's in here. So x squared goes here, negative 3 goes in here. This is probably x times x gets me x squared. I need to figure out what times what gives me 3, so it's probably got to be 3 and 1. I check to see if this is right. X times 3 gives me 3x in here. X times 1 gives me 1x in here. Can I combine these to get... Oops, I messed up somewhere. No one caught it. This should be a 2. 2 times negative 2x gives me that negative 4x. Oh, Aslan, speak up. All right, let's see. So here, can 3x and 1x make negative 2x? Yes, if I make this negative and this positive. All right, so here's what I got. I've got y equals, I still have my 2 that was factored out front, and now I've got x minus 3 and x plus 1. Factored form. Yay. Okay, I'm about to ask a question. I want everyone in the room to think about this. Second period really struggled with this question, and maybe it's because I worded it weird. But when we were doing factored form, we were solving quadratics, right? You had an assignment called solving quadratics by factoring. It was kind of a tough assignment, all right? Your equations did not look like this. They looked a little bit different. They started in standard form, you factored them, but there was one thing about this equation that looked different on that assignment. Can anybody tell me what that was? No. It didn't have y equals. What did it have? It didn't have f of x either. When we were solving quadratics, it always said equals 0 in the back. You remember that?
Yeah.
When we were solving quadratics, it always said equals 0 in the back. I want you to see something right now and have a full understanding of what the heck we're talking about here. Okay, watch this. Let's pretend like this did not say y equals right here. Let's pretend like it said equals 0. And in front and back, it doesn't matter. So I'm changing y to a 0. So it says equals 0. The reason I'm doing that is because when we solved quadratics, it said equals 0. Okay, I'm nervous about asking this question. When we were solving quadratics by factoring and we got to this step, imagine it says equals 0. What was the next step to solve? Kind of. There's one thing I want you to say before that, Michael, but you're right. No distributing.
Oh,
Yes.
isn't it when you get the final answers of both of them? It's like x, you would, for 0, you would like add 3, and then you would.
That's what Michael was saying, and let me just stop you. Here's what I was looking for you to say. You set each factor equal to 0. We took a step where we did x minus 3 equals 0, and we did a step where x plus 1 equals 0. Then we did what Adriana and Michael were saying is add 3 to both sides, subtract 1 to both sides to get our answers. Okay? So, here's what I want you to see. X minus 3 equals 0. Let's pretend like we're solving this right now. Add 3 to both sides and you get x equals positive 3. X is positive 3 when y is 0. That's where this comes from. Okay? So our solutions, our answers when you solve, are the 2 places where it crosses the x-axis because that's where y equals 0, and that's why we have equals 0 when we're solving quadratics. Okay? The other one, x plus 1, set it equal to 0. Minus 1 from both sides, you get x equals negative 1. There's your other answer. X equals negative 1 when y equals 0. Okay, so that's where our answers are. Next thing you need to know. These 2 points are so important, mathematicians gave them 4 names. Okay, one name of these are solutions. Because when you solve a quadratic, these are the 2 solutions you get. Another name, x-intercepts. Kind of duh, right? It's where it crosses the x-axis. 2 more names. One name, and this one kind of makes sense. They call these zeros. Is it obvious why they call them zeros?
Yeah.
It's when y equals 0. Okay? The last name that they call them, and I don't know where this came from, is roots. You probably, I think you had a question on one of your assignments already talking about roots. These are also roots. Okay, so 4 names, that's how important they are. All right, let's keep going. I'm going to attempt to draw my parabola in now. Please don't make fun of me. There's no way I do it as good as I did this one, but I'm going to try anyway. Oh, I was doing good. No, that's bad. Edit that video afterwards to make that look perfect if you can. Okay, all right, so there's our parabola. This leading coefficient of 2, a was 2 up here, yes? In standard form, a was 2. Here in factored form, a was 2. Here in vertex form, a is 2. A is just always chilling out front. That's why we call it the leading coefficient. It's just always 2. It does not affect your vertex. It does not affect your roots where it comes.
Who just died.
Bishop Glass just dropped the heaviest Hydro Flask of all time.
God damn.
All right, anyway, moving forward. It does not affect the roots. It did not affect the vertex. It only affects two things. How wide or narrow the parabola is. So this is a narrow parabola because of that 2. And it also affects, if it were -2, it would flip. Okay? All right. Moving on. We are almost done with this video. Thank God. There's a couple more things from Alex I have to tell you. If a vertex is at the bottom, it has another name. What is that name? Minimum. Thank you, whoever that was. Great job. If a vertex is at the top, maximum. Yay. Okay. Alex asks this weird question every once in a while where they ask you, what is the value of the minimum or maximum? Super weird question. What is the value of the minimum or the maximum? What they are asking you is, how low is your minimum or how high is your maximum? They just want to know how high or how low it is. This minimum is -8 low. Make sense? It's just really looking for the y value. How low is it? How high is it? Okay? All right. One more thing that Alex is going to ask you on today's assignment is average rate of change. And I need you to associate the phrase rate of change with one algebra word and always relate those two things together. Anybody know the algebra word I'm talking about?
Slope.
Slope. Slope. Rate of change is slope. Okay, watch this. Okay, I got people not listening anymore. That's fine. Quadratics test next week's going to be terrible for you. All right. Let's say a question asks this. What is the rate of change for this function, or this quadratic, or this parabola? What is the rate of change for this function between x equals -1 and x equals 2? So from here to here, what is the rate of change in that interval? Okay, at -1, our parabola is right there, yes? At 2, where is our parabola? Down here? At 2, our parabola is right there. So it is basically asking, what is the average rate of change between here and here? Rate of change is slope, so just do rise over run. Okay, to get from here to here, we went down 1, 2, 3, 4, 5, 6. We went to the right 1, 2, 3. So down 6, right 3, rise over run, -6 over 3. So average rate of change is just -2. Okay, so you're literally just finding out where your function is at those two spots and finding the slope. Okay, that is average rate of change. Yes?
Could your slope be like the A?
That was just a coincidence. The question was, is our slope always A? That was a coincidence. Okay, all right. Eyes up front. Last part. Let's do domain and range, axis of symmetry, and then we will be done. All right, domain and range, I always introduce it the same way. Hopefully it sticks one day. Domain is us writing down all of the x's that are on this parabola. However, this parabola has infinity points, which would mean we're writing down infinity x's, and we don't want to do that. So instead, we're just going to write all the x's are from the furthest one to the left to the furthest one on the right, and everything in between, all infinity in between. So we need to know, how far does this parabola go to the left? What you need to know about parabolas is they do get wider and wider and wider as they go up. So it'll continue to go left and left and left slowly, but it'll keep going left forever. So how far to the left does it go? -infinity. Okay? How far to the right does it go? Same thing, positive infinity. The other way to say this is all real numbers. Okay? Range, not the case. All right? And by the way, we always go smallest to biggest. So furthest to the left to furthest to the right. Same with range. Smallest to biggest. So lowest to highest. This parabola does not go down to -infinity. It only goes down to, oops, undo. It only goes down to -8. Does it actually get to -8 and touch -8? Yes, there is a point there, 1, -8. It is actually a point right there at -8. So we need to include -8 as part of our range. It's not every number leading up to -8 and then right before there, no. It is including -8, it does get there. All right, how high does it go? Positive infinity, parenthesis, because you can never include infinity. Okay, last one, axis of symmetry. Parabolas are symmetrical. Okay, the axis of symmetry is the line right down the middle that shows on both sides of that line it is symmetrical. Okay? When you're asked for the axis of symmetry, they want to know what is the equation of that line. Okay? People always forget the equations of vertical lines. This is at x equals 1. Okay? And it's got to go right through the vertex, through the x coordinate. X equals 1 is the equation of that axis of symmetry. And we usually show axis of symmetry with a dotted line, by the way. Yes, ma'am?
It's not a question.
Okay.
Can we go to the bathroom real quick?
Yeah. All right. That's it. That was a long one. It's been fun. I'll see you on the next video. Deuces.